Children, once again welcome to our physics class. Hope you all are fine over there. In the previous session we had discussed about superposition of waves. Okay, so today let's discuss about superposition principle once again, and also let's discuss the most important concept, that is interference, which is based on this superposition principle. Okay, so let's find out an expression for the intensity of waves during interference. Okay children, and we will also discuss the famous Young's double slit experiment to observe the interference of light waves. So let's get started. So what is superposition principle? When two or more waves traveling through a medium superimpose on each other, the resultant displacement at any point is equal to the vector sum of displacements due to individual waves at that point. So we had already observed the superposition of waves in our previous sessions, and we had discussed about constructive and destructive superposition. Suppose we have n waves superimposing at a point. Let y1, y2, y3, etc. yn be the amplitude of those waves, or y1, y2, y3, etc. yn be the displacements due to different waves traveling through a medium. Then according to the principle of superposition, the resultant displacement y is equal to y1 plus y2 plus y3 plus etc. plus yn. Okay, so this is the superposition principle. When two or more waves traveling through a medium superimpose on each other, the resultant displacement at any point is equal to vector sum of displacements due to individual waves at that point. Next, let's discuss, or let's do a mathematical analysis of this superposition principle. Children, let's go for a mathematical analysis of superposition. Here you can see two waves, and these two waves are not in same phase. They have same frequency, but they are not in same phase. There is a phase difference. These two waves doesn't start at the same time and doesn't end simultaneously. Here you can see the peak of the wave, but at the same time this point corresponds to the minimum of the wave. This wave is only about to start. So there is a phase difference, and let phi be that phase difference. So phi is the phase difference between these two waves. A is the amplitude of the wave. And you had already learned in your class 11 physics how to represent a wave using a wave equation. So this is the wave equation for the first wave, y1 equal to a cos omega t. I hope you remember this wave equation. A wave can be represented by this equation, y1 equal to, or y equal to a cos omega t. And since we have represented two waves here, let the displacement of first wave be denoted by y1. So this wave, first wave, is denoted by y1 equal to a cos omega t, where a represents the amplitude of the wave. And let the second wave be represented by y2 equal to a cos omega t plus phi. This phi represents the phase difference, because there is a phase difference between these two waves. Now, whenever these two waves reach the screen simultaneously, see, this is the screen, and here you can see both the waves reach the screen simultaneously. So they will superimpose each other. And as per superposition principle, when such waves superpose each other, the resultant displacement y is given by y1 plus y2. Now substitute y1, y2 in this expression. So you will get a cos omega t plus a cos omega t plus phi. A is common factor here, so take it outside. So you will get y is equal to a into cos omega t plus cos omega t plus phi. Now the terms in the bracket is in the form cos A plus cos B, and there is an identity in mathematics. Cos A plus cos B is equal to 2 cos A minus B by 2 cos A plus B by 2. So here A is omega t and B is omega t plus phi. So 2 cos A minus B by 2. A minus B by 2 is cos phi by 2. You can just check it. And cos A plus B by 2 will be cos 2 omega t plus phi all divided by 2. Okay. So you can remove the bracket and you can write y is equal to 2a cos phi by 2 cos 2 omega t by 2 is omega t plus phi by 2. Okay. And this above equation, that means this equation represents a wave with an amplitude of 2a cos phi by 2. So in this wave equation, this portion represents the amplitude of the resultant wave. Resultant wave means wave obtained by the superposition of these two waves. So 2a cos phi by 2 represents the amplitude of the resultant wave. And once we get the amplitude, we can easily find out the intensity. Because what is the relationship between intensity and amplitude? Intensity is equal to amplitude square. So here amplitude is 2a cos phi by 2. So intensity is equal to square of this expression, that is 4a square cos square phi by 2. And this a square can be denoted by I naught. I naught means intensity of the original wave or the original intensity, and this is the intensity of the resultant wave. Okay, so this is the equation to find out intensity of during indifference or during superposition. Now we need to find out the condition for maximum amplitude and minimum amplitude from this expression. That's our aim. Maximum amplitude means brightness is observed on the screen, constructive superposition occurs, and minimum amplitude means darkness is obtained on the screen, that is destructive superposition occurs. So when this amplitude, when do this amplitude maximum? Amplitude will be maximum when cos phi by 2 is maximum. That means maximum value of cos phi by 2 is plus 1 or minus 1. So amplitude 2a cos phi by 2 is the amplitude, and this amplitude will be maximum when the value of cos is maximum. That is when cos phi by 2 is equal to plus or minus 1. At this positions at this points, cos phi by 2 will be maximum. And when do this cos function takes plus 1 or minus 1 value. So when the value of phi is, or when the value of theta is 0, pi, 2 pi, 3 pi, etc. n pi, isn't it? Cos 0 is 1, cos pi is minus 1, cos 2 pi is 1, cos 3 pi is minus 1. It goes on like that. So when phi by 2 is 0, pi, 2 pi, 3 pi, etc. to n pi, cos phi takes values of plus or minus 1. So if phi by 2 is this, then what is phi? We need to find out phase difference phi. Phi is equal to, just multiply 2 with all the terms here. So phi is equal to 0, pi into 2, 2 pi, 2 pi into 2, 4 pi, 3 pi into 2, 6 pi, n pi into 2, 2 n pi. So this is the condition for brightness or maximum amplitude. So when phase difference is 0, 2 pi, 4 pi, 6 pi, or generally 2 n pi. When phase difference is 2 n pi, brightness is obtained on the screen. Similarly, from the phase difference, we can find out the condition for path difference. How? See, a phase difference of 2 pi corresponds to a path difference of lambda. Okay, a phase difference of 2 pi corresponds to a path difference of lambda. So here, a phase difference of 0 corresponds to a path difference of 0. Phase difference of 2 pi corresponds to path difference of lambda. Then phase difference of 4 pi will correspond to path difference of 2 lambda, because if 2 pi is lambda, then 4 pi will be 2 lambda, 6 pi will be 3 lambda. It goes on like that. And 2 n pi will be n lambda. Okay, so when path difference is 0, lambda, 2 lambda, 3 lambda, or generally n lambda, brightness is obtained on the screen. So what is the condition such that the amplitude is maximum or brightness is obtained on the screen? Phase difference should be 2 n pi. Okay, phase difference should be 2 n pi. This is the condition for maximum intensity or brightness. Again, path difference should be n lambda, integral multiple of lambda. Phase difference should be 2 n pi. path difference should be n lambda. So these are the conditions to obtain brightness on the screen. Then what are the conditions to obtain darkness on the screen? So amplitude will be minimum when the value of cos will be minimum, that means 0. So when do this cos theta takes 0 values? Cos 90, 0. Cos 270, 0. So it goes on like that. Odd multiple of pi by 2. Whenever theta is odd multiple of pi by 2, cos of theta will be 0. So here theta is 5 by 2. So 5 by 2 is equal to pi by 2, 3 pi by 2, 5 pi by 2, and it goes on like that. Generally we can say if phase difference, then how can we write the phase difference? Phi. So here from this phi is equal to, just multiply 2 with each terms here. So here you will get pi, 3 pi, 5 pi, etc. to n minus 1 into pi. Okay, so when phase difference is odd multiple of pi, that means 2n minus 5, you will get darkness. Darkness is obtained on the screen. And similarly, what will be the condition for path difference? You know, a phase difference of 2 pi corresponds to lambda, then a phase difference of pi corresponds to lambda by 2, isn't it? Phase difference of pi corresponds to a path difference of lambda by 2. So here phase difference of pi corresponds to path difference of lambda by 2. 3 pi, 3 lambda by 2. 5 pi will be 5 lambda by 2. And 2n minus 1 into pi will be equal to 2n minus 1 into lambda by 2. So these are the two conditions to obtain darkness or minimum amplitude on the screen. Phase difference should be odd multiple of pi and path difference should be odd multiple of lambda by 2. Okay, so you must always remember the conditions for brightness and darkness. Condition for brightness is phase difference should be 2n pi, path difference should be n lambda, and condition for darkness is phase difference phi should be 2n minus 1 into pi and path difference should be 2n minus 1 into lambda by 2. Okay.